Sleep physiology. Importance of sleep. What is sleep? Sleep is an altered state of consciousness in which there is a loss of reaction of brain to environmental stimuli. During sleep, the brain activity does not cease, but state of conscious experience is lost, which is reversible. Analysis of sleep and diagnosis of sleep disorder are accomplished with the help of EEG, electroencephalography. It is basically recording electrical activity of the brain with the help of surface electrodes placed on the scalp. Its recording depends on summation of excitatory postsynaptic potential and inhibitory postsynaptic potential IPSP. They are both synaptic potential and are local depolarization, which is not the action potential. EEG shows four different types of waves: alpha waves, beta waves, theta waves and delta waves. Alpha waves is 8 to 12 cycles per second, beta waves is 13 to 30 cycles per second, theta waves is 3 to 7 cycles per second and delta wave is 0.5 to 2 cycles per second. Theta and delta waves are basically slow waves, while beta waves is desynchronized wave. Alpha wave is seen in parietal occipital lobes. They appear on closing eyes and disappear on opening eyes. They also disappear if there is mental activity with eye closed. Beta waves seen in frontal and parietal lobes. These appear during awake state and during REM sleep. Theta and delta are seen in parietal and temporal lobes. These slow waves are seen during stage 3 and stage 4 of non-rapid eye movement sleep. While occurrence of theta and delta rhythms is normal during sleep, their appearance during wakefulness is a sign of brain dysfunction. States of sleep. Two types of states of sleep are observed by recording EEG, electroencephalogram, electromyogram, EMG and EOG, that is electrooculogram. The first one is non-REM sleep or slow wave sleep. Second is REM sleep or paradoxical sleep. REM sleep is also regarded as desynchronized, while slow wave sleep is also regarded as synchronized sleep. So this chart table shows the difference between slow wave sleep and paradoxical sleep. EEG slow wave sleep displays slow waves. Paradoxical sleep displays EEG of alert or awake person, that is beta waves. Motor activity is there is a considerable muscle tone during slow wave sleep and there is a frequent shifting in the muscle tone, while in paradoxical sleep there is an abrupt inhibition of muscle tone and there is no movement. Heart rate, respiratory rate and blood pressure, there is a minor reduction in slow wave sleep, while there is a irregularity in paradoxical sleep. Dreaming. Dream rarely occurs in slow wave sleep, but even then whenever there is a dream, these dreams are not remembered in slow wave sleep. Paradoxical sleep, dreams are very common and they are remembered. Arousal. So slow wave sleep, sleepers are easily awakened, while it is very hard to arouse person in paradoxical sleep. The threshold for arousal is increased 5 to 10 times as compared to slow wave sleep. Percentage of sleeping time. Slow wave sleep accounts for 80%, while paradoxical sleep accounts for 20%. Other features of slow wave sleep are it has 4 stages, stage 1, 2, 3, 4. And paradoxical sleep there is a rapid eye movement. So rapid eye movement also occurs even in blind individuals. Other features of paradoxical sleep are there is an increase in cerebral blood flow and oxygen consumption. There is a penile erection in male and engorgement of clitoris in female. Teeth grinding, bruxism may be seen in children during paradoxal sleep. Normal sleep cycle. Sleep always begins with non-REM sleep, and first REM period usually occurs 90 to 100 minutes after the onset of sleep. Again, person goes into non-REM sleep. Normal night sleep consists of 3 to 5 such alternating cycles of non-REM and REM sleep. Person can wake up after an episode of non-REM or REM. Awake and alert, there's a beta waves, awake but drowsy, alpha waves, stage 1 drowsy, alpha and theta brain waves, stage 2 light sleep. There's a sleep spindle and K complex, which represents memory consolidation during stage 2. Stage 3 moderate to deep stage, there's a theta and delta brain waves, while in stage 4, which is the deepest stage of non-REM sleep, there will be the delta brain waves. Now sleep then lightens and enter the state that is REM sleep, where there is a vivid dreaming, fast active beta waves with rapid eye movement. So time spent in various stages of sleep in an adult. Non-REM sleep, which accounts for 80 to 85%. Stage 1 is 5 to 10%. Stage 2, which is the longest, 50%. And stage 3, 15%. Stage 4 is 10%. REM sleep is about 15 to 20%. Again, this is the same EEG figure at different stages of sleep. Drowsy alpha waves, stage 1 theta waves, stage 2 sleep spindle and K complexes representing memory consolidation. Stage 2 is the longest duration during the sleep. Stage 4 delta waves, synchronized wave, and its feature is low frequency but high amplitude. REM sleep, it is desynchronized sleep or desynchronized wave with high frequency and low amplitude. Positron emission tomography scanning in humans shows that neuronal activity increases in pons, amygdala and cingulate gyrus during REM sleep. This figure shows normal sleep cycles at various ages. Children, young adults and elderly. REM sleep is indicated by darker color areas. In a typical night of sleep, a young adult first enters non-REM sleep, passes through stages 1 and 2 and spends 70 to 100 minutes in stages 3 and 4. Sleep then lightens and a REM period follows. This cycle is repeated at interval of about 90 minutes throughout the night. The cycles are similar, though there is a less stage 3 and stage 4 sleep and more REM sleep towards the morning. Duration of REM and stage 4 decreases gradually with advancing age. So in elderly people, REM sleep and stage 4 of non-REM sleep gradually decreases, while in newborn and infants they sleep 18 to 20 hours a day, of which 50% is spent in REM sleep. Now we come to the last discussion, that is importance of sleep. Slow wave sleep or non-REM sleep, it is responsible for recuperation of body functions, while REM sleep allows expression of concerns through dreams in subconscious mind. REM sleep helps in long-term learning and memory. In infants and young children, widespread excitation of brain that accompanies REM sleep is important for maturation of developing nervous system. Myelination indicates structural maturation of brain, while duration of REM sleep indicates functional maturity. REM sleep in adult, it helps in maintenance of synaptic continuity. So with this we come to an end of today's discussion regarding sleep and its importance. Next topic will be on neural mechanism of sleep, in which we will learn about different theories of sleep, and then we will also discuss about sleep disorder. So this ends our discussion. Thank you.